So, hello everybody. We're gonna be talking about cybersecurity today, and this is basically our introduction into the unit. So, in the next few meetings, we're gonna be talking about a lot more specific stuff, and it'll be very fun. So, this is basically hacking, right? So, cybersecurity is preventing hacking, but in order to prevent hacking, you gotta understand how it works. So, that's why this is gonna be kind of cool. So why is cybersecurity relevant, right? So for smaller companies, it is not that relevant, but as more people start to use your stuff, right, you don't want people to just be able to break it just whenever the heck they want, right? So essentially, the whole point of cybersecurity is to make it so that people can't ruin your years of hard work. Okay, so here's some funny headlines that are actually pretty recent. Like these were both yesterday. So the first one not that funny, but basically like a Chinese hacker group hacked into Microsoft yesterday or something, and guess what they used? Which Microsoft app they used? Anyone have any ideas? Well, what is a meme Microsoft app? No.
Skype.
Not quite, dude. They really used the like Microsoft's Exchange, which is their email email app. So and they managed to hack into a bunch of people's personal data. And then, ironically, this Formula One team, which is the racing team, they have a cybersecurity firm as their sponsor. This Acronis thing, and they still got hacked. It's kind of funny. But anyways, now let's just talk about some security principles before we get into the actual fun stuff. But the first principle that you gotta know is security is economics, right? How much security do you actually need? Like, if you're storing like $5 or $100, which one would you put more security on? Anybody? Basically, like this is why you don't put like $100 bills in your wallet, right? Like your wallet is not that secure, so you don't if you don't have that much security, you don't want that much money at the same time, right? So the higher the stakes, the more security you're gonna want. Also, usability, right? It needs to be usable. You can't make everybody use random strings of passwords because nobody could remember that, right? Like that's the idea behind password managers. And this is a very good, a very good cartoon, right? Basically, in a perfect world, if nobody's able to use anything, it's technically very secure, right? So obviously, if you want if you want to log in, stare directly at the sun, so it's impossible to log in. And no security through obscurity. Okay. Could anybody tell me why like putting a Rubik's cube like as your lock is a bad idea? Anybody? Why would you not want a Rubik's cube? Like making somebody solve a Rubik's cube to get into your house. Why is that a bad idea?
They either know how to do it or they don't know how to do it.
Yeah, exactly, right? So, like, the main problem with this is that once somebody learns how to solve a Rubik's cube, they can enter your house whenever the heck they want, and you would have to design a completely new puzzle in order to prevent them from getting it, right? Which is bad. But how does the keypad, for example, change this?
Only the owner knows how to solve it.
Yeah, like everybody who uses the keypad knows how it works, right? If you put in the right code, it's gonna let you into the house, right? But only the owner knows the code. So even though everybody knows how it works, only the owner can get into the house. So that's like good security, because you don't have like, even if somebody finds out the code, all you gotta do is change the code, and hooray, you've already like fixed the problem. Nobody else will be able to get into your house. Okay, so this is just a lock picking example, right? So locks are, everybody has locks in their house, right? You just put a key in, you turn it. The reason why that's good is because it's pretty easy to get into and out of your house. You just put in the key and turn it, right? But if you guys have watched The Lock Picking Lawyer, it's actually very easy to pick locks if you know how they work, right? So like, does anybody know what these things are called? These things that move up and down in the lock are called?
Pins.
Pins, exactly, right? And basically, this like bronzy thing turns, right? But unless these lines are lined up with that bronze thing, it's not gonna turn. So essentially, what a key does is it has the exact right height, so that these things align up right with the bronze thing, and now it could turn. So how could you take advantage of this, knowing how a lock works? So how could you open a door without the key?
You can like line up the key pins one by one.
Exactly. That's exactly what they do, right? They take this little pick that goes in. They go to the first pin, they push it up the same right amount. Then they go to the second pin, push it up just to the right amount, and then eventually they got all the pins, and then they turn the whole lock, and you're in, right? So technically, locks are really bad. So like, a keypad lock is always going to be better than like one of these kind of locks. Okay, and another thing, design security in from the start. Don't just like slap it on, right? Like no matter how strong your lock is, if you have a like horrible door, it's not gonna actually keep anybody out, right? You can just break it. Like this stuff seems not very useful, right? So whenever you're making a program or anything, you probably want to make sure that you have security at the beginning. And of course, security is your weakest link, right? You can have as strong a lock as you want, but if there's another weak part and people could get through that way, then they're going to use that weaker part. Okay, so let's talk about like a fun hacking example that's like very applicable, and it was actually a very big problem until like the language that people use for databases changed to fix it. So let's just say we have a normal login screen where you take in a username, you take in a password, okay? And this is how the password management, or like how you check if a user put in the right password, right? So basically, it goes into your database and it runs this code, right? So it basically finds a user where the username is the given username and the password is the given password. And if they don't find a user, then you put in the wrong password, right? So basically, if you put in the input, like if that was my username and that's my password, then it would put it in and run this code, right? So why is this a problem? Any ideas? What could somebody do with this? Like, this code seems pretty like, this seems like not problematic, right? We're just checking if it exists in the database. But what's the problem with running code that is influenced by the user? Any ideas? What happens if the input included a quotation mark? What happened then? Any ideas? Nobody has an idea what problems could be happening if like you're running as an admin, you're running like code that the user put in. Why is that a problem? Nobody has an idea.
They could just predict the code and just write the code that's needed.
Yeah, exactly, right? They could put like whatever code they want into our program and run whatever the heck they want. So basically like people could do a lot of naughty stuff if they could guess how your code looks, right? So if they put this as their username, seems like a very good username, right? But if they put this as your username, you could basically like it'll put this in, it'll put that like it'll end off this, and then it'll say drop table users and comment out the rest of it. And guess what drop table users does? Any ideas? Databases store things in tables.
Deletes all the usernames?
Yeah, it deletes the entire database. So essentially, this guy, just by putting in the right input, deleted the entire database just by putting in the right username. Then if you wanted to log in as an admin, so essentially this guy could log in anybody he wants, right? He just puts his like a username, puts the end quote, puts the colon, and comments out the rest, so it doesn't even check his password, right? So essentially it's kind of funny, but like this is called SQL injection, and it's like a legit thing that people could do if you're not careful. So essentially, to do well in cybersecurity, like there's a lot of skills you could learn, and I'll be going over a couple of them right now, but these are some of them. You got to know how to use inspect element, because what could inspect element help you with when you're trying to hack a website, let's say? Why would you want to inspect element on a website to hack it? What does inspect element do? Any ideas? Okay, fine. It's like, what does it do? Like, not even considering hacking. What does doing inspect element do? Like, what could you see about the website?
Give you access to CSS and HTML.
Yeah, you could see the code of the website, right? And if you know how a website works, you could hack it, right? Like, if you know how a website works, you could hack it. So essentially, what like a lot of websites do now is that they do like server-side rendering, so they only send you the bare minimum, so you actually don't know how the website works. But people used to actually put the code on the website, which means that people could see how it works and hack it. And then you could like learn all this other stuff too. So let us learn some cybersecurity on the job. So there's this really big cybersecurity competition coming up in a week, and if you guys are interested in this kind of stuff, I'll put out a form and I'll help you guys find teams. But I'll just show you guys a couple examples of cool questions that were really fun to do from 2 years ago for this. So let me look for it. So essentially, like, they have this like game over here, which is pretty fun. So if you guys wanted to practice or well, I guess they don't. The game's not working right now. But let us do forensics. So forensics is basically like hiding messages in like in like different ways. So let's try this one. Okay, so essentially we had to find a secret message in this blank page. Okay. All right. Anybody have an idea what we could do? So clearly there's stuff here, right? But we can't see it. But does anybody know like how to actually see spaces? Like anybody?
I think you might be screen sharing the wrong thing.
Oh yeah, whoops, my bad. Let me screen share my whole screen. So essentially this is the text file they gave us, and it's just a bunch of spaces, right? You can't see anything. But does anybody know how we could possibly like see what the coding for these spaces is? Like what the actual like what type of space these are? Any ideas? Someone put something in chat. Okay, well let's try that. So if I open my terminal and we go to downloads and we do cat white pages .txt, let's say. It's still like a bunch of empty stuff. Clearly there's stuff here because there's all this stuff, but we can't actually see what type of space they are. So any other ideas? Like how are characters encoded? Does anybody have an idea how things are encoded? Like text files? Like how is the letter how does the
You
letter
convert
like
to binary.
Yeah, we want to see the binary of this text file, right? So essentially, like, I mean, you guys probably do not have this. Why can't I open this? Okay, yeah, so you guys probably do not have this program, but there's a program that lets you see it. So we could go here, we could right click, open with hexfiend. Okay. So there you go. Basically, there is a bunch of, like, this is the binary, right? Or like it's in hexadecimal, but that's just another way of representing binary. And you can see there are two types of spaces. There's this type of space, which are like E20, 80, 83. And then there are the normal spaces, which are just 20s, right? So what do you guys think that this, like, there's two types of spaces, okay? So what do you guys think this is an encoding for? Any ideas? How could we convert two different things into Morse code? A good guess, but it turns out that this is just straight up binary, okay? So what we're gonna do is we're gonna write up a script in order to decode this. So let us go to our text file. Let's copy and paste this, okay? And we are going to do decoder.py. And we're gonna do text is equal to that. Very nice. Okay. And essentially we want to find two of the different types of spaces. So space type 1 or space 1 is equal to like the normal space, and space 2 is equal to like the first space that we found on our text file. So let's copy and paste the first space. Okay. Alright, very nice. So essentially we could just go through our text. So for C in text, we could if C equals space 1, we print out 1, and otherwise we print out 2. I mean 0. Let's say 0. Okay. So we do python decoder.py. Whoops. Okay, let's encode it. 8. Hold up. Wait for it. Okay, let's see. Maybe it's ASCII. Okay, well, basically this is the idea. I forgot the exact thing, but essentially you could basically convert all these like specific spaces to ones, convert them all to zeros, and then it'll eventually give you the actual binary for a flag. Okay, so that's one cool thing. And then another cool thing we could do is web. Okay, so which one was it that was cool? Open to admins. This was fun. Okay, so essentially what the problem says, hold up, so we go to web. Okay, so essentially it's saying that only if the cookies, admin and time are exactly these, we could get the flag, right? So if we go here, we try to get the flag, it says, oh, it doesn't look like you're an admin, and it's not the correct time. So does anybody know how to change cookies using Google Chrome? Anybody?
This is an inspect element.
Yes, okay, that's the first step. So we go to inspect element. Now, anybody know where the cookies tab is? Which one we're looking in? Okay, I'll give you it. It's in here, right? So now we can actually just change the cookies ourselves. So we can say admin, true, and we can set time to equal 1400. And if we do flag now, we get the flag. So essentially, this is also what does this tell us about cookies? Like in terms of security, what does this tell us? If we're able to hack it using cookies and we're able to change cookies however we want, what should we not use cookies for? Any ideas? Well, basically the point is, if we're able to change whatever if a person's able to change their cookies, we should not use cookies to store passwords or use it to store usernames, right? Like cookies should be secure, and they're not. So essentially, like by seeing how we can hack this, you could basically see that cookies are not a good way to keep things secure. Let's do another one. Let's see. Let's see. Pico browser. Okay. Let's try this one. So essentially, this one's saying, I have to use the right type of browser in order to access the flag, but Pico browser does not exist. So how might we do this? Does anybody know how to impersonate other browsers? Anybody? This is actually kind of fun, but essentially you could go to inspect element. You could go to over here. You could go to network conditions. Okay, and we could change our. Hold up. You could change this to Pico browser, right? And now, if we get the flag, we got the flag. It's pretty cool. So basically the whole point of like hacking competitions is that you could like figure out these really cool you could basically find these vulnerabilities in programs, and you could get like pretty cool results. Hold up, let's see what else we could possibly do. What could we do? Okay, what about this one? Or no, let's do don't use client side. Okay, does anybody know what client side means? Anybody? Nobody? Okay, so I said server side is they render it on the server side, right? What does client side mean? Anybody? No? Client side basically means they render it, they send you all the code. So how could we look at the code for this website? Anybody? No? Okay, well, essentially you could click inspect element. You could see that if let's try expanding this. Okay, so basically it literally tells you exactly how they check your password. Okay, so essentially you can see that they split the password into a bunch of things, so we can figure out the password. So the first one is pico, then CTF is the next one, then we look for split times 2. Let's see. No C, or let's do it in a different tab so it's easier. Okay, so we do pico CTF, no C. Okay, where is 3 4 no client? So I'm assuming clients 3 to 4. Okay, client P, and then 5. Please. Nice. Okay, and then we got 6A8E, and then the last one is B. Okay, and hooray, we've basically found the password. If we try verifying it, let's try it. Hey, and it says password verified, right? So essentially this is another reason why like you don't want to like give people your code, right? Because if they could read your source code, they know how it works. Oh, my bad. Okay, how do I do this? Hold up. So what else could we potentially do? Are there any particular topics you guys want me to try out? Anything? Let's see, what else is interesting? Huh. These ones are kind of like time consuming to do, so let's see, cryptography maybe? Okay, let's try this. Someone put something in chat. OSINT? No, dude, OSINT is too hard, man. No. Okay. Well, basically, we could do cryptography, right? So, does anybody know what a Caesar cipher is? Fun, what's it called? Computer science trivia for you guys. Any ideas? Nobody knows what a Caesar cipher is? This is so sad. Nobody? Come on, somebody, tell me what a Caesar cipher is, I beg.
Just shift the alphabet over by n.
Yeah, exactly, right? And basically, this is talking about ROT13, so guess what ROT13 is? This is a type of Caesar cipher. What do you think 13 stands for?
Is it just a plus 13?
Yeah,
Caesar
exactly,
shift?
right? So essentially it says, a simple Caesar substitution cipher that rotates alphabet characters by the specified amount. We put it in there, and hooray, we got our very cool code. Very nice. See what else there is. Easy one. Let's see. Okay. One-time pad. So another cool thing is this thing. So essentially, like, you know how there's like symmetric and asymmetric cryptography, right? So symmetric cryptography means that if two people have the key, they could send each other messages, right? And essentially, this is the easiest symmetric cryptography that that works, right? You basically take a key and a message and you XOR them, and you get your message. So does anybody know what XOR means? What an XOR does? Any ideas? What is the definition? What does XOR stand for? Anybody? No? Okay, well, XOR stands for exclusive OR, and what's really pretty cool about this is that if we put in a UTF-8, whoops, not that. Hold up. Oh, I should probably decode from ASCII to hex. Hold up. From, where is this? ASCII or UTF? Let's see. From ASCII. Oh wait, that should be fine. Let's see. Oh, there's a table. Let's see. Oh, nice. Okay, so I guess we had to use this table, huh? Oh wait, this is the Vigneer cipher. Okay, so let us see. Vigneer cipher decoder. And basically, cryptography is just a bunch of different types of ciphers. So if we use this, I don't know why it asks for one-time pad when it is just this thing. Okay. And we can put in the key. Crypto is fun, very nice. And you got another password over here. So that is basically a taste of what you could do with hacking. There's a lot of fun problem solving you could do. And I would highly suggest that you guys sign up for picoCTF because it's really, really fun. There's a lot of, you learn a lot of skills in terms of using computers and stuff. So I would highly recommend. So that is all we got for today. Anybody have any